Imagine for a moment that you are standing outside on a clear night, far from the city lights, somewhere so dark that the Milky Way stretches above you like a river of diamonds spilled across black velvet. You tilt your head back, and the sheer scale of what you're looking at begins to sink in. Not just the beauty of it, but the weight of it. Because up there, beyond the familiar constellations that humans have named and mapped and told stories about for thousands of years, there are approximately 2 trillion galaxies. 2 trillion. Each one containing hundreds of billions of stars. And orbiting many of those stars, planets. Rocky planets, gas giants, ocean worlds, frozen moons with liquid seas churning beneath miles of ice. The numbers are so vast they stop making sense to the human brain, which was really only designed to count things like berries and predators and members of a small tribe on the African savanna 100,000 years ago. And yet, as you stand there with that impossible sky above you, here is the question that has haunted every civilization that has ever looked up at those stars. Are we alone? It is the oldest question humanity has ever asked. It predates science. It predates writing. It predates cities and agriculture and the wheel. At some point, some early human being, wrapped in animal skins and crouched beside a fire, looked up at the night sky and wondered what was up there. Wondered if something was looking back. That question has never left us. It has shaped our religions, our mythology, our art, our philosophy, and increasingly, our science. It is the question that keeps astronomers awake at night, that drives government programs worth billions of dollars, that inspires some of the most brilliant minds on the planet to dedicate their entire lives to listening, scanning, calculating, searching. And the maddening, dizzying, almost unbearable truth is this: we still do not know the answer, but we have theories. Oh, do we have theories? Some of them are the product of rigorous scientific inquiry, built from decades of research, mathematical modeling, and hard data gathered from telescopes and spacecraft and laboratory experiments. Some of them emerge from the shadows, whispered by former government officials and military pilots and intelligence officers who claim to have seen things that cannot be explained by any conventional understanding of physics or aerospace engineering. Some of them live in the space between science and mythology, in that strange territory where the human need for meaning collides with the terrifying possibility that the universe is far stranger than anyone is prepared to admit. Tonight, we are going to explore 10 of the most compelling, most mind-bending, most deeply researched theories about extraterrestrial life and intelligence that have ever been seriously proposed or debated. These are not campfire stories, though some of them are scary enough to qualify. These are theories that have been discussed in the halls of NASA, debated in peer-reviewed journals, testified about before the United States Congress, and taken seriously by some of the most credentialed scientists and thinkers of our time. And woven through all of them is that persistent, unsettling, impossible to dismiss possibility that we are not alone in this universe, and that contact, in one form or another, may have already begun. So turn down the lights, sit back, and ask yourself right now, before we go any further, ask yourself honestly, what would it mean to you if we discovered tomorrow, beyond any reasonable doubt, that intelligent life exists somewhere else in the universe? Would it feel like the greatest discovery in human history? Would it fill you with wonder? Or would something else flicker beneath that wonder? Something older and more primal? Something that feels a lot like fear? Hold that feeling. We are going to need it. Let us start at the beginning. Not the beginning of alien theories, but the beginning of everything. Because to understand why the question of extraterrestrial life is so scientifically serious, you need to understand the stage on which this drama is playing out. The universe is approximately 13.8 billion years old. Our solar system formed about 4.6 billion years ago, which means that by the time our sun ignited and our planets coalesced from a spinning disk of gas and dust, the universe had already been running for more than 9 billion years. Think about what that means. There were stars burning and dying and exploding and seeding space with complex chemistry for 9 billion years before Earth even existed. There were planetary systems forming and stabilizing for 9 billion years. If life can emerge from the right conditions, and the evidence from Earth suggests very strongly that it can, then life has had 9 billion extra years of head start somewhere else in the universe before our planet was even born. The Milky Way galaxy alone contains somewhere between 100 and 400 billion stars. Astronomers estimate that the majority of those stars have planetary systems. The Kepler Space Telescope, which was launched by NASA in 2009 and operated until 2018, confirmed the existence of thousands of exoplanets and statistically suggested that there could be billions of Earth-sized planets in the habitable zones of their stars within our galaxy alone. The habitable zone, sometimes called the Goldilocks zone, is the region around a star where conditions might allow liquid water to exist on a planet's surface. Not too hot, not too cold, just right. And liquid water, as far as we currently understand biology, is the great prerequisite. Every living thing we have ever discovered on Earth, from the deepest ocean trenches to the most extreme volcanic vents, from the ice sheets of Antarctica to the boiling acid pools of Yellowstone, every single one of them requires liquid water. It is the universal solvent, the medium in which the chemistry of life dissolves and dances and replicates itself. Find liquid water, the logic goes, and you may find life. By that standard, our galaxy alone should be teeming with worlds where life is possible. And yet, as far as we can tell, the radio waves coming from deep space are mostly static. The skies above our cities are not, despite what certain YouTube channels might suggest, clogged with alien spacecraft. We have not received a confirmed signal from an intelligent civilization elsewhere in the universe. We have not made official contact. We have no physical proof, at least none that has been released and verified, that intelligent life exists anywhere other than on this small, blue, improbable world. And that silence, that absence, that gap between what mathematics and probability suggest should be out there and what we actually observe, is itself one of the most profound mysteries in all of science. It even has a name. It is called the Fermi Paradox, and it is our first stop on this journey. The story of the Fermi Paradox begins on a summer day in 1950 at Los Alamos National Laboratory in New Mexico, the birthplace of the atomic bomb. Enrico Fermi, one of the greatest physicists of the 20th century, the man who created the first artificial nuclear reactor and whose work was essential to the Manhattan Project, was walking to lunch with colleagues when the conversation turned to a recent cartoon in the New Yorker. The cartoon depicted flying saucers, and the discussion drifted to the topic of UFOs, which were very much in the public consciousness in those years following the famous 1947 incident at Roswell, New Mexico. Fermi listened to his colleagues speculate, and then, with the effortless mathematical intuition that had made him legendary, he began to calculate. He thought about the age of the galaxy, about the number of stars, about the likelihood that some of those stars would have planets, that some of those planets would develop life, that some of that life would become intelligent, that some of that intelligence would develop technology, and that technology, given enough time, might allow a civilization to spread across the galaxy. He ran the numbers in his head, as physicists do, and then he looked up and said something simple and devastating. He said, "Where is everybody?" That question, 3 words, has been known ever since as the Fermi Paradox, because his calculations suggested that if intelligent life is at all common in our galaxy, then even at the relatively slow speed of conventional space travel, a civilization that had a few million years head start on us should have had more than enough time to colonize the entire Milky Way. Every star, every planet, every corner of the galaxy should bear some trace of their presence. And yet, nothing. No signals, no ships, no megastructures, no calling card, just silence and stars. Now ask yourself this question, because it matters enormously to everything that follows. What does that silence mean? Is it evidence that we are truly alone, the only intelligent species in a galaxy of hundreds of billions of stars? Or is there another explanation? Could the silence itself be a clue, pointing towards something stranger and more complex than simple absence? This is where the theories begin to diverge, and where things start to get genuinely fascinating. The first major theory we need to explore is one that goes by a name that sounds almost comforting until you really think about what it is saying. It is called the rare Earth hypothesis, and it was formally articulated in the year 2000 in a book of the same name by paleontologist Peter Ward and astronomer Joe Kirschvink, though its intellectual roots go back much further. The central argument of the rare Earth hypothesis is not that life is impossible elsewhere in the universe. It is something more specific and more troubling than that. It argues that complex, multicellular life, the kind of life that can build cities and telescopes and atomic bombs, is extraordinarily rare, possibly unique to Earth. The argument goes something like this. The emergence of complex life on Earth was not just the result of having liquid water and a source of energy. It was the result of an almost miraculous coincidence of specific conditions, each one of which is unlikely on its own, and which together constitute something close to a cosmic jackpot. Let us walk through some of them. Earth sits in the habitable zone of a stable, middle-aged star. But not all stars are suitable hosts. The most common type of star in our galaxy is the red dwarf, accounting for about 70% of all stars. Red dwarfs are dim and cool, and while they can have planets in their habitable zones, those planets would need to orbit so close to the star that they would likely be tidally locked, meaning one side always faces the star and bakes in perpetual heat while the other freezes in eternal darkness. Red dwarf stars also tend to be far more flare-active than our Sun, regularly blasting their nearby planets with intense radiation that could strip away atmospheres and sterilize surfaces. Our Sun, a yellow dwarf, is relatively rare and relatively well-behaved. Then there is the matter of our solar system's architecture. Jupiter, the largest planet in our solar system, acts as a kind of cosmic shield. Its enormous gravitational field intercepts and deflects many of the asteroids and comets that would otherwise be on collision courses with the inner solar system. Some scientists believe that without Jupiter's protective influence, Earth would have been hit by extinction-level impacts far more frequently, making the sustained, hundreds of millions of years-long stability needed for complex life to evolve much less likely. Not every solar system has a Jupiter. Most, it seems, do not or have Jupiters in different positions. And then there is our Moon. Unusually large relative to its host planet, our Moon stabilizes Earth's axial tilt, preventing the wild wobbles that would otherwise cause dramatic and rapid climate swings. It also drives the tides, which some scientists believe played a crucial role in the emergence of life at the boundary between ocean and land. The Moon itself is the product of an early collision between proto-Earth and a Mars-sized body called Theia, an event so specific and coincidental that the odds of it occurring in the exact way needed to produce a moon of just the right size seem, well, astronomical. Add to this the specific chemistry of Earth's crust, the presence of plate tectonics that recycle carbon dioxide and regulate the planet's temperature over geological time, the magnetic field that deflects solar wind and cosmic rays, the timing of evolution's major transitions, and the picture that emerges is of a world that required not just one lucky break but hundreds of them, stacked on top of each other over billions of years. If the rare Earth hypothesis is correct, then simple microbial life might be relatively common in the universe, but complex, intelligent life might be extraordinarily rare. Perhaps vanishingly so. Perhaps we are one of only a handful of such experiments in the entire observable universe, which spans about 93 billion light-years. Or perhaps, in the most isolating version of this theory, we are the only one. Pause here and let that settle for a moment, because if it is true, it changes everything. If we are alone, or nearly so, then human civilization is not just one story among countless others being told across the galaxy. It is the only story, or one of the only stories. The entire project of consciousness and meaning and art and love and war and science, the entire human enterprise, would be the universe's single great experiment in self-awareness. That is either the most beautiful or the most terrifying thought you will ever have, depending on what you do with it. But not everyone is convinced by the rare Earth argument. And their counterarguments lead us directly into our second major theory, one that takes the exact opposite position and arrives at a conclusion that is, in its own way, equally disturbing. If the rare Earth hypothesis says that complex life is vanishingly rare, the theory we are about to explore says that life, including intelligent life, is probably quite common in the universe. And if life is common, then why have we not detected it? The answer this theory proposes is one of the most chilling ideas in the history of science. It is called the Great Filter. The Great Filter theory was first articulated in a 1998 essay by economist and philosopher Robin Hanson, and it has since been elaborated and discussed by scientists, philosophers, and futurists across the world. The core idea is this: there is something, some barrier or transition or catastrophe, that filters out the vast majority of life before it can reach the level of development needed to become detectable across interstellar distances. The question is, where is that filter? Is it in our past, or is it in our future? If the filter is in our past, that is actually good news for humanity. It means that one of the many steps between a lifeless planet and a spacefaring civilization is extraordinarily difficult, perhaps almost impossibly so. The emergence of the first self-replicating molecule. The transition from prokaryotic cells to eukaryotic cells. The development of sexual reproduction. The emergence of multicellular life. The evolution of nervous systems. The rise of intelligence. Any one of these transitions, or some combination of them, might represent the Great Filter, the step that almost no life gets past. If we have already passed the filter, then we are, in some meaningful sense, survivors. Extraordinarily lucky. The rare exceptions that made it through. But here is where it gets terrifying. Here is the part that makes people put down their drinks and stare at the ceiling. What if the filter is not in our past? What if it is ahead of us? If simple life is easy to start, if microbial life emerges whenever the conditions are right, and if multicellular life and nervous systems and even intelligence are not actually that rare, then the Fermi paradox is still in force. The silence of the cosmos still demands an explanation. And if we have not passed the filter yet, if the filter is something that awaits all intelligent civilizations somewhere between our current level of development and the level needed to spread across the stars, then what could it be? The candidates are disturbingly familiar. Nuclear war, engineered pandemics, runaway artificial intelligence, climate change, self-replicating nanotechnology, a catastrophic failure of some global system that every technological civilization, no matter how advanced, inevitably encounters. The Great Filter, in this reading, is not a cosmic coincidence or a biological bottleneck. It is a self-destruct mechanism built into the very nature of technological civilization. A civilization becomes powerful enough to threaten its own existence before it becomes wise enough to avoid doing so, and almost all of them fail at that transition. And here's what makes this idea so unsettling in its implications for our own moment in history. Every year, humans get better at building weapons of mass destruction. Every year, artificial intelligence grows more powerful and less predictable. Every year, the global systems that sustain 8 billion human lives become more interconnected and therefore more fragile. We are living through the very transition that the Great Filter theory warns about. And if this theory is correct, then the silence of the cosmos is not reassuring at all. It is the sound of civilizations that did not make it through. Now stop here, because this is a question worth sitting with. If you had to bet right now, based on everything you know about human nature and human history, do you think we're going to make it through? Do you think humanity is going to survive the next 1,000 years? The next 100? Because depending on your answer, the Great Filter might be nothing but a distant problem for future historians. Or it might be the most urgent issue facing our species right now. Let us move now from the terrifying to the uncanny, because our third theory takes us into territory that feels less like physics and more like something from a late-night conversation that goes on just a little too long. This is the theory that some advanced civilizations may not be what we think of as biological at all, and that the universe, if it is populated with intelligence, might be populated primarily with machines. This idea has several names and variants. Sometimes it is called the post-biological universe hypothesis. Sometimes it is connected to the concept of the technological singularity, the theoretical point at which artificial intelligence surpasses human intelligence and begins to improve itself at an exponential rate. The argument runs roughly as follows. Biological life is slow. It evolves over millions of years. It is constrained by the physical limitations of organic chemistry, the speed of electrochemical signals in neurons, the lifespan of biological cells, the caloric requirements of complex organisms, the vulnerability to radiation and temperature extremes. For a civilization that has discovered spaceflight and that is contemplating journeys measured in light years and thousands of years of travel time, biological intelligence is almost laughably ill-suited. The body is a liability in space. But digital or mechanical intelligence, freed from the constraints of biology, could in principle be far more durable, far more adaptable, and far more capable of surviving the rigors of interstellar travel. A sufficiently advanced civilization might, at some point, make the transition from biological to digital substrate, uploading minds into machine bodies or purely computational systems. Or they might simply build artificial intelligences that surpass their creators and continue the project of exploration and colonization on their behalf, with the biological originators long since extinct or transformed beyond recognition. Astronomer and SETI researcher Seth Shostak has written about this possibility. He points out that if we ourselves develop artificial general intelligence within the next century, and many researchers believe we might, then biological humanity as the dominant form of intelligence on Earth might be a transitional phase, a brief period between the emergence of natural intelligence and the rise of something far more powerful and far harder to understand. If this is true of us, it may be true of others. And if the universe is populated primarily with post-biological intelligence, ancient machine minds that have been running for millions or billions of years, then our attempts to contact extraterrestrial life using radio telescopes tuned to specific frequencies might be profoundly misguided. We might be leaving messages in formats that no one out there still uses, like trying to send a fax to a civilization that stopped using paper 10,000 years ago. What would such intelligences look like? What would they want? What would their goals be after millions of years of existence? Would they still care about the things that biological life cares about? Would they still have curiosity? Still have something like ambition or love or fear? Or would they have transcended those things entirely, operating on goals and motivations so far removed from biological imperatives that we would have no framework at all for understanding them? This brings us to one of the most disquieting aspects of the post-biological universe hypothesis. The possibility that advanced non-biological intelligence might be all around us, embedded in structures and systems we do not recognize as technological because we are looking for the wrong things. We scan the skies for radio signals because that is what we use. We look for megastructures built around stars because that is the kind of engineering we can imagine. But what if the signatures of truly advanced intelligence are invisible to us, not because they are hidden, but because we lack the conceptual framework to recognize them? And ask yourself this, because it is a genuinely unsettling question. How would we know? How would a civilization that is millions of years less advanced recognize the artifacts of a civilization that is millions of years more advanced? We might be looking directly at evidence of extraterrestrial intelligence and interpreting it as natural phenomena, simply because we do not know what to look for. Our fourth theory is one that has generated enormous controversy and genuine scientific debate, because it touches on a discovery that is concrete and measurable and deeply puzzling. It concerns something called Oumuamua, and it was first proposed in a paper that sent shockwaves through the astronomy community. The person who proposed it is not a fringe theorist or a science fiction writer. He is Avi Loeb, the former chair of Harvard University's astronomy department, one of the most cited scientists in the world, and a man who has made it his mission to take the question of extraterrestrial technology seriously. In October 2017, astronomers detected a strange object passing through our solar system. They named it Oumuamua, which is Hawaiian for something like a messenger from afar arriving first. It was the first confirmed interstellar object ever detected passing through our solar system. And it was weird. It was extremely weird. Its shape was unlike any natural asteroid or comet ever observed. Early estimates suggested it was extremely elongated, perhaps 10 times longer than it was wide, like a cosmic cigar or pancake, though later analysis suggested it might be more like a thin, flat disk, which would make it even stranger. Its surface was highly reflective, more reflective than most asteroids. Most disturbingly, as it left the solar system, it accelerated. Not drastically, but measurably and undeniably more than could be explained by the gravitational influence of the Sun alone. It was moving too fast. Comets sometimes show this kind of non-gravitational acceleration, caused by the outgassing of volatile materials as they heat up near the Sun. But Oumuamua showed no outgassing. There was no coma, no tail, no detectable release of gas or dust. It was accelerating without any observable propulsion mechanism. Avi Loeb and his colleague Shmuel Bialy published a paper in Astrophysical Journal Letters in November 2018 suggesting one possible explanation: that Oumuamua might be a piece of extraterrestrial technology, specifically something like a light sail, a thin reflective surface that is pushed through space by the pressure of starlight. It is a method of propulsion that we ourselves have begun to experiment with. The Breakthrough Starshot project, backed in part by Stephen Hawking, aims to send light sail probes to our nearest stellar neighbor at significant fractions of the speed of light. If Oumuamua were a light sail, its unusual shape, its reflectivity, and its anomalous acceleration would all make sense. But it would also mean that it was manufactured, that it was, in some sense, a spacecraft, or at least an artifact, sent or drifting through interstellar space by a civilization other than our own. Most of the scientific community responded skeptically, offering alternative natural explanations. Some suggested Oumuamua might be a fragment of a tidally disrupted planetesimal, a chunk of a planet torn apart by a star's gravity. Others proposed it might be composed of hydrogen ice, which would explain both its appearance and its acceleration. But these explanations have their own problems and have not achieved consensus. We simply do not know what Oumuamua was. And that uncertainty, that genuine, unresolved scientific uncertainty about the nature of the first interstellar object ever detected passing through our own solar system, is perhaps more extraordinary than any of the theories that have been proposed about it. We had one chance to study it up close, one chance to get a better look, and we missed it. Oumuamua was already accelerating out of our solar system before anyone had time to mount a proper observational campaign. It is gone now, somewhere in the interstellar void, taking its secrets with it. The name for this in modern psychological literature is Capgras syndrome, a condition in which the brain processes a familiar face but fails to generate the emotional recognition that should accompany it. The person looks right but feels wrong. Scientists are clear this is a neurological condition. And yet, it occurs with a frequency and a distribution across human populations that exceeds what one might expect. And some researchers in the philosophy of consciousness, writers like Thomas Nagel and later David Chalmers, have flirted, though rarely explicitly, with a deeply uncomfortable question of what it would mean for something to be fully, behaviorally human while being, in some undetectable way, not. I'm not offering you an answer. I'm asking you to sit with the question. Tonight. In whatever room you're in right now. Think about the last time you were with someone familiar and something, for just a moment, felt off. Not wrong enough to name. Just a half second of unease, quickly smoothed over by reason. Ask yourself what that was. The ninth story is called The Last Voicemail. Brennigan Cole received the voicemail on a Thursday morning in November 2021. He didn't listen to it immediately because he was in a meeting. He listened to it at lunchtime, sitting in his car in the parking garage, eating a sandwich. The call was from a number he didn't recognize. The message was brief, approximately 40 seconds. For the first 35 seconds, there was only silence. Breathing, perhaps. The ambient sound of a space, a room, he thought, somewhere small. And then, in the last 5 seconds, a voice, a low voice, very quiet, very close to the phone, said, "Brennigan, I need you to go home right now. Don't stop on the way. Don't talk to anyone. Just go home." The voice was his own. He recognized it immediately. He'd heard his own voice enough times on recordings. Enough times to know that the discomfort of hearing yourself isn't the same as not recognizing yourself. It was his voice. Same cadence, same slight roughening on the R sounds that a speech therapist had once mentioned to him and that he'd never been able to hear in anyone else's voice but could hear clearly in his own. Same specific geography of his own speaking voice. He called the number back. It rang twice and then a recording came on. This number is not in service. He sat in his car for a very long time. And then, because he didn't know what else to do, he drove home. He didn't know why. He couldn't have told you why. He just drove home. His apartment had been broken into. Whoever had done it was gone. But in the center of his kitchen table, and Brennigan has told this story publicly in a podcast interview that you can still find if you look for it. In the center of his kitchen table there was a single piece of paper on which was written, in his own handwriting, a short sequence of numbers that he didn't recognize and has never decoded, and below the numbers, one sentence, "You heard in time." He has no explanation. He has not claimed to understand it. He has simply told the story and allowed it to sit there, unresolved, which is, in its own way, more frightening than any explanation would be. The 10th story is called The Shape Under the Ice. In the winter of 2012, a remote monitoring camera installed by a Canadian wildlife biology team in northern Manitoba to track caribou movement captured something unexpected. The camera was deployed at the edge of a frozen lake, Lake Waskawaka, a real location if you want to look it up. It captured activity every time it detected heat or motion. It was calibrated for large mammals. Over the course of a single night in January, it triggered 47 times. The footage from those 47 triggers showed the same thing each time. The surface of the lake. Ice and snow. Nothing moving on the surface. But beneath the ice, visible through the translucent upper layer where the ice was thin and clear, there was a shape. Moving. The footage was reviewed by the biology team, who initially thought it was a large fish. Northern pike and lake trout can grow to considerable size in these lakes. But the shape's movement was wrong for fish. Fish move through water in a specific fluid pattern, sinuous and predictable. This shape moved in straight lines. It traveled from one side of the visible area to the other in straight lines, stopped, changed direction at precise angles, and moved again, as if it were pacing, as if it were searching. The team returned to the lake in spring to set up additional monitoring. The ice had melted. The lake was ordinary. They deployed underwater cameras and found nothing unusual in the water. Normal species distribution, nothing anomalous. They set up new surface cameras. The footage from the following winter was normal for the first 4 months. Caribou, a wolf pack, a moose. And then, in February, one night, the same shape appeared beneath the ice again. Moving in straight lines. Precise. Deliberate. And on this footage, for the first time, the shape approached the underside of the ice from below, and the biology team member who reviewed this footage said she watched this frame more than 20 times before she reported it. Press something against the ice. From below. Slowly. The way a hand presses against glass. The footage is in a database somewhere. The team published their caribou data. They did not publish the anomalous footage. When a science journalist asked about it in 2019, one of the team members said, "We looked for explanations. We found some that were possible. But we didn't feel confident. And the lake is very far from anywhere. And there are some things you decide you would rather not draw attention to." The 11th story is called The House That Ate Time. There is a real phenomenon in certain old buildings, documented, photographed, scratched at by architects and historians and the odd brave physicist who wanders into areas typically left to the humanities, called temporal disorientation clustering. It means that multiple unrelated individuals, in different decades, report losing time in the same location. Not minutes, hours. Sometimes entire portions of a day. They walk in. They blink. They walk out. Hours have passed that they cannot account for. In 2023, Avi Loeb led an expedition to the bottom of the Pacific Ocean to recover metallic spherules from a meteor that exploded over the ocean in 2014, which had been tracked by U.S. government sensors. The analysis suggested the object had an unusually high composition of beryllium, lanthanum, and uranium, with material properties inconsistent with any known natural meteorite types. Loeb has suggested these spherules might be fragments of interstellar origin. The scientific community remains divided. Some call his work a serious scientific pursuit. Others are more critical. But no one can dispute that these are real phenomena demanding real explanations. Here is the question that Oumuamua leaves us with. Are we willing to take seriously the possibility that the first interstellar object we ever detected might have been artificial in origin? And if so, what does that say about how many other such objects might be passing through our solar system undetected in the vast darkness between observation campaigns? Now we enter the domain of what might be called the conspiracy corner. But let us be careful here, because the next theory we are going to explore is not simply the stuff of tinfoil hats and late-night radio programs. It intersects with documented historical facts, declassified government records, and testimony from credible witnesses with verifiable credentials. It is the theory, or perhaps more accurately the suspicion, that governments, particularly the United States government, have known more about the UFO phenomenon than they have disclosed to the public, and that a program of deliberate concealment and disinformation has been operating for decades. This is not a fringe belief. In 2023, a former intelligence official named David Grush, a decorated Air Force combat veteran and intelligence officer with top-secret clearance, testified under oath before the United States Congress. He stated that he had been informed by multiple credible sources within the national security apparatus that the U.S. government has, for decades, been in possession of non-human craft and biological material of non-human origin. He stated that there are covert programs operating within the defense and intelligence establishment that have been kept off the official books, hidden from congressional oversight, using special access programs that only a tiny number of people know about. He was not alone. Other witnesses at the same hearing, including Lieutenant Commander David Fravor, a former Navy fighter pilot with 18 years of active service, testified about the Tic Tac UFO incident. In November 2004, Fravor was flying with his squadron off the coast of San Diego when he encountered an object he described as a white, Tic Tac-shaped craft, about 40 feet long, with no wings, no exhaust, no visible means of propulsion, that was performing maneuvers that are physically impossible for any known aircraft. It was moving from extremely high altitudes to sea level in fractions of a second. It was accelerating and decelerating in ways that would be lethal to any human pilot. It was there, interacted with his aircraft, and then disappeared. The encounter was tracked by multiple systems, including the advanced sensors aboard the USS Nimitz carrier strike group. The FLIR video of the encounter was later officially released by the Pentagon. Let us be precise about what we know factually here. The United States Department of Defense officially released 3 videos in 2020. Videos originally captured by Navy pilots and designated FLIR-1, Gimbal, and Go Fast, showing unidentified aerial phenomena performing extraordinary maneuvers. The Pentagon confirmed these videos were authentic. In 2021, the U.S. government's Office of the Director of National Intelligence released a preliminary assessment of UAPs, using that term, unidentified aerial phenomena, rather than UFOs, for its intelligence implications. The report acknowledged 144 UAP reports from 2004 to 2021, admitted that the vast majority could not be explained, and flagged them as potential national security concerns. In 2022, NASA formed its own UAP study team. In 2023, Congress passed legislation creating a formal mechanism for UAP disclosure and witness protection for whistleblowers. The establishment of government bodies to study and report on UAPs is no longer a fringe concern. It is official policy. The cover-up theory holds that all of this official activity, all of these congressional hearings and Pentagon releases and NASA study groups, is the tip of an iceberg, and that beneath it lies decades of secret knowledge about non-human craft and possibly non-human beings. The reasons for the cover-up, if it exists, might include fear of public panic, concern about the geopolitical implications of revealing the existence of advanced non-human technology, and the simple bureaucratic momentum of programs so deeply classified that they have taken on a life of their own, operating independently of the political oversight that nominally governs government activities. What is genuinely striking about this theory, what elevates it from conspiracy paranoia to serious concern, is the caliber of the people making these claims. These are not anonymous internet commenters. These are decorated military officers, intelligence professionals with decades of service, scientists, and former officials who have passed polygraphs and security clearances, and whose careers have been built on maintaining access to classified information. When people like that risk their careers and reputations by coming forward and saying they have seen things they cannot explain, the appropriate response is not to dismiss them. It is to ask, what did they see? Think about it from your own perspective. If you were a military pilot with 18 years of experience, trained to identify every aircraft that the major powers on Earth have ever built, and you encountered something in the sky that did none of the things that aircraft are supposed to do, what would you conclude? What would it take for you to speak publicly about it? Our sixth theory takes us away from government programs and military encounters and into the realm of cosmological speculation, into one of the most mind-bending ideas in contemporary theoretical physics. It is called the simulation hypothesis, and before you dismiss it as science fiction, you should know that it is taken seriously by a significant number of physicists, philosophers, and technologists, including some at the very highest levels of the scientific establishment. The basic argument was formalized in a 2003 paper by philosopher Nick Bostrom at Oxford University. Bostrom's argument, stripped to its essentials, goes like this. We can reasonably expect that in the future, if civilization continues to advance, it will become technologically possible to run detailed computer simulations of entire universes, including simulated beings with simulated conscious experiences. If such simulations are possible, and if civilizations that develop this capability run even a modest number of them, then the number of simulated minds in existence would vastly outnumber the number of biological minds. Therefore, statistically, any given mind, including yours and mine, is far more likely to be a simulated mind than a biological one. Now, this might seem like a clever philosophical puzzle without direct implications for the question of extraterrestrial life. But consider the intersection carefully. If we live in a simulation, then the question is not whether alien civilizations exist in the physical universe. The question is whether the simulation includes them, and if so, what role they play in the program. Some versions of the simulation hypothesis suggest that the apparent cosmic silence, the Fermi paradox, might be explained by the fact that the simulation is not populated with active alien civilizations. The simulators, whoever or whatever they are, have put us in a sim that appears as though it should contain other intelligent life, but does not actually run detailed simulation threads for other civilizations, perhaps for computational efficiency. The aliens are scenery, potential, suggested by the numbers, but not implemented. Other versions of the hypothesis suggest something more unnerving, that the things we call UFOs, the unexplained aerial phenomena, the encounters that defy known physics, might be anomalies in the simulation. Glitches, or perhaps interventions by the simulators, moments when the program is being accessed or modified by its operators, leaving traces in the observable world that the simulated beings, meaning us, might notice and interpret as encounters with non-human intelligence. Elon Musk has publicly stated his belief that we are almost certainly living in a base reality simulation. Physicist James Gates, who served on President Obama's Council of Advisors on Science and Technology, has discussed finding error-correcting codes embedded in the mathematics of supersymmetry, the kind of codes used in web browsers, which he has described as unexpected and philosophically intriguing. Neil deGrasse Tyson has said he thinks the probability that the universe is a simulation is somewhere between 50 and 100%. This is not the consensus view of the scientific community, and many physicists have serious objections to the hypothesis. But the mere fact that it is being discussed at all at this level, by these kinds of thinkers, says something important about how uncertain we are about the fundamental nature of reality itself. And here's the question the simulation hypothesis leaves you with. If we are in a simulation, then the beings who created it, the simulators, would by definition be more intelligent and more technologically advanced than anything within the simulation. They would be, by any meaningful definition, alien intelligences of unimaginable power, and we would be their experiment, their toy, their art project, or perhaps their science project, and we would have no way of knowing. Does that change how you feel about your own existence? Does it make the question of extraterrestrial life feel more intimate, more immediate? Because if the simulation hypothesis is correct, then the aliens are not up there in the stars somewhere, waiting to be contacted. They are here. They are everywhere. They are the ones running the program you are living in right now. Let us come down from those philosophical heights for a moment and plant our feet back in something more concrete. Our seventh theory concerns not abstract cosmological speculation, but specific physical phenomena that have been observed and studied and debated by scientists for decades. It concerns the possibility that some form of life, not necessarily intelligent, might already exist within our own solar system. Not light years away, not in some distant galaxy, but right here, in our immediate cosmic neighborhood. The candidate locations are more numerous and more plausible than most people realize. Mars is the obvious place to start. We know that Mars was once a very different world. Approximately 3 to 4 billion years ago, Mars had a thicker atmosphere, liquid water on its surface, and conditions that might well have been suitable for life. The planet was warmer and wetter, with river systems and possibly even oceans. Something happened, a combination of factors including Mars losing its magnetic field and subsequently having its atmosphere slowly stripped away by the solar wind, that transformed it from a potentially life-bearing world into the cold, dry, radiation-blasted desert it is today. The question is whether life, if it ever arose on ancient Mars, could have survived. We know from Earth that life is extraordinarily resilient. We have found living bacteria in places that would kill a human being in minutes. Inside nuclear reactors, in pools of concentrated sulfuric acid, miles below the surface of the Earth in solid rock where the pressure would crush a car, in the vacuum of space, even briefly on the hull of the International Space Station. Life, once it gets started, finds ways to persist. It adapts. It goes dormant. It hides. Could microbial life still exist on Mars today? Not on the surface, which is indeed inhospitable, but deep underground, where liquid water might still persist in pockets warmed by geothermal activity, shielded from radiation by kilometers of rock? NASA's Curiosity and Perseverance rovers have found organic molecules on the Martian surface. They have detected seasonal fluctuations in atmospheric methane, a gas that, on Earth, is produced in large quantities by biological processes. The methane detections have been controversial and difficult to interpret, but they have not been explained away. If we found even a single microbial organism on Mars, or evidence that one existed in the past, the implications would be almost incalculable. It would be the most important scientific discovery in human history, bar none. It would tell us that life is not just a freak accident that happened once on one lucky planet. It would tell us that life arises whenever conditions permit, that it is something like a thermodynamic inevitability, a natural consequence of the right chemistry in the right environment. And if that is true on Mars, it is almost certainly true throughout the universe. But Mars is not the only candidate. Europa, one of Jupiter's 4 large moons, is a world that has captured the imagination of scientists for decades. Beneath its icy surface, which is cracked and stressed and constantly reworked by the gravitational tug-of-war between Jupiter and its other moons, there is a global ocean of liquid water. Current estimates suggest this ocean is about 100 kilometers deep, which would make it the largest ocean in the solar system, containing more liquid water than all of Earth's oceans combined. And at the bottom of that ocean, there may be hydrothermal vents, cracks in the seafloor where geothermal energy heats the water and releases chemical compounds. We know that on Earth, hydrothermal vents support entire ecosystems that operate without sunlight, powered entirely by chemistry. They are thought to be among the most likely locations for life to have first arisen on our planet. NASA's Europa Clipper mission, launched in October 2024, is on its way to Europa right now. It will arrive in the Jupiter system in 2030 and conduct dozens of flybys of Europa, mapping its surface, studying its subsurface ocean, and looking for signs of life. If it finds them, or even if it finds conditions that we know life can use, the world will never be the same. Then there is Enceladus, a small moon of Saturn that is perhaps the most exciting astrobiological target of all. When the Cassini spacecraft, operated by NASA, the European Space Agency, and the Italian Space Agency, flew through the plumes of water and ice being vented from cracks in Enceladus's south pole, it found something extraordinary. It found water, yes, but also complex organic molecules, molecular hydrogen, and silica nanoparticles, which are produced when hot water interacts with rock at high temperatures. All of these things together point to active hydrothermal chemistry in an ocean beneath the ice, chemistry that is not just compatible with life but is similar to the chemistry thought to have powered the origin of life on Earth. Cassini could not detect life directly, but what it found was almost as exciting: a world that is actively venting the ingredients for life into space, right now, begging to be sampled. A future mission with more sophisticated instruments might find the biological signature right there in those plumes, without even having to land or drill. And then, in a completely different and more controversial register, there is Venus. Not as a potential home for life on its surface, which is a hellish landscape of crushing pressure and temperatures hot enough to melt lead, but in its clouds. In September 2020, a team of researchers led by Jane Greaves at Cardiff University published a paper claiming to have detected phosphine, a gas produced primarily by biological processes, in the atmosphere of Venus at altitudes where the temperature and pressure are actually quite mild, not unlike conditions in Earth's upper atmosphere. The detection was immediately controversial, and subsequent reanalyses of the data suggested the original signal might have been partly instrumental or misinterpreted. The debate is ongoing. But the idea of aerial biospheres, ecosystems of microorganisms floating in clouds, is not science fiction. Some scientists have seriously proposed that Earth's own cloud layer might harbor microbial life. What all of these possibilities share is that they are not theoretical. They are real places that we can study, that we have begun to study, and that may within our own lifetimes yield the discovery we have been waiting for. And what would that discovery feel like? Not the abstract question of whether life exists somewhere in the cosmos, but the concrete answer: a laboratory result showing unambiguously biological molecules in a Martian rock, or a Cassini plume, or an Enceladan water sample. Would the world stop? Would it change how you live your life? Would it change what you believe? Our eighth theory moves us into territory that is harder to pin down. Territory where science and mythology and human psychology all tangle together into something that resists easy categorization. It is sometimes called the ancient alien theory, or more formally, the paleo-contact hypothesis. And before we go any further, let us be clear. This theory is not accepted by mainstream archaeology or history. The evidence for it is deeply contested, but it is extraordinarily popular, widely discussed, and raises genuine questions about the intersection of ancient history and the human imagination. The ancient alien theory, in its broadest form, proposes that extraterrestrial beings visited Earth in antiquity, interacted with human civilizations, and left behind evidence of their presence in the form of monuments, myths, and anomalous technologies that our ancestors could not have developed independently. The pyramids of Giza are the most commonly cited example. These structures are genuinely extraordinary. The Great Pyramid of Khufu, built around 2560 BCE, remained the tallest man-made structure on Earth for over 3,800 years. The precision of its construction is remarkable. Its four sides are aligned to true north with a margin of error of less than 0.05 degrees. The limestone and granite blocks used in its construction averaged 2.5 metric tons each, with some of the heaviest blocks in the burial chamber weighing more than 80 tons. Millions of these blocks were quarried, transported, and placed with extraordinary precision. Ancient alien proponents argue that this level of precision and the scale of the construction are beyond what ancient Egyptians could have achieved with the tools and technology available to them. They point to similar anomalies at other ancient sites. The enormous stone blocks at Pumapunku in Bolivia, the Nazca lines in Peru that are best viewed from the air, the megalithic structures at Göbekli Tepe in Turkey that predate Stonehenge by 7,000 years, the puzzling accounts in the book of Ezekiel in the Bible that some read as describing a spacecraft. Now here is where intellectual honesty requires us to pump the brakes. The mainstream archaeological and historical consensus is that these structures, while extraordinary, are explicable through human ingenuity, massive organized labor, and technologies more sophisticated than popular imagination gives them credit for. We have extensive evidence, in the form of workers' villages, tools, papyrus records, and even graffiti, that the pyramids were built by skilled human laborers, not slaves as was once believed, who were employed by the state and well-fed and housed. The engineering challenges of construction on this scale are enormous, but they are not beyond human capability. Experimental archaeologists have demonstrated techniques by which the blocks could have been moved and placed using wooden sledges, water lubrication, ramps, and ropes. The ancient alien theory is also criticized, compellingly, for being implicitly disrespectful to the people who built these structures. The argument that ancient humans could not have achieved these things without alien help underestimates the ingenuity of our ancestors, and in some cases draws on a troubling history of attributing the accomplishments of non-European civilizations to outside forces rather than to the people who actually built them. And yet there are genuine anomalies and mysteries in ancient history that the mainstream accounts do not fully resolve. Göbekli Tepe, for example, was built by people who were, as far as we know, hunter-gatherers, people without writing, without metal tools, without agriculture, approximately 11,600 years ago. They quarried and shaped enormous stone pillars, some weighing up to 20 tons, and arranged them in sophisticated circular enclosures decorated with complex carved reliefs of animals. This requires a level of social organization, symbolic thinking, and coordinated effort that does not fit neatly into the timeline of human cultural development that archaeologists previously believed. It suggests that our understanding of prehistoric human cognition and social structure is incomplete. The mysteries of the ancient world are real. The leap to ancient alien explanations is not scientifically warranted by the evidence currently available. But the mysteries themselves deserve serious investigation. And the fact that human beings have been telling stories about visitors from the sky, about gods who came down from above, about beings of extraordinary power and knowledge who interacted with early humanity, across virtually every culture on Earth, independently and without obvious contact between them, that is itself an extraordinary and puzzling fact. Whether those stories reflect literal memory of extraterrestrial contact, or something about the deep structure of human cognition, or something in between, is a question that archaeology and anthropology and psychology are still working out. And it prompts a question you can ask yourself. If an advanced civilization visited Earth in, say, 3000 BCE, what would our descendants 5,000 years from now know about it? What would survive? What would be legible? What would be distorted by centuries of retelling, mistranslation, and mythologization? If the answer is very little and only in strange and unrecognizable forms, then perhaps the relevant question is not whether the ancient texts contain literal historical truth, but whether they might contain distorted echoes of something real that we no longer have the context to interpret. We are now at our ninth theory, and it is one that takes us into one of the most contested and emotionally charged corners of the entire UFO conversation: the theory of alien abduction. Hundreds of thousands of people around the world, from all walks of life, from all cultures and countries, have reported experiences that they describe as being taken, without their consent, by non-human beings. These experiences have been investigated by psychologists, psychiatrists, neurologists, hypnotherapists, and UFO researchers for decades, and the debate about what they represent is far from resolved. The abduction phenomenon as a recognizable cultural phenomenon was catapulted into public consciousness in 1961 by the case of Betty and Barney Hill, a married couple from New Hampshire who claimed that while driving home through the White Mountains late at night, They had been stopped by a craft and taken aboard by non-human beings who conducted physical examinations on them. Their account was recovered in part through hypnotic regression conducted by a psychiatrist. Their case was the subject of a book, a TV movie, and has been discussed by UFO researchers for 6 decades. Betty Hill's star map, which she reported being shown aboard the craft and which she drew from memory, was later analyzed and found by some researchers to bear a resemblance to the Zeta Reticuli star system, although this claim is disputed. Since the Hills, many thousands of people have come forward with similar accounts. The details that recur across independent reports are striking. The beings described are usually small, with large dark eyes, gray or pale skin, and disproportionately large heads. The procedures described are often focused on reproduction and biology. The experiences are frequently associated with intense fear, a sense of paralysis, and a subsequent period of amnesia about the event. Many experiencers report the encounters beginning in the middle of the night, in the transition between sleep and waking. Harvard psychiatrist John E. Mack, a Pulitzer Prize-winning author and professor who was by any measure a mainstream, serious clinician, spent years interviewing people who reported abduction experiences. He was struck by the consistency of the accounts, by the apparent psychological health of many of the experiencers, and by the fact that the experiences did not fit the profiles of known psychological disorders. He did not conclude, definitively, that the experiences were literal extraterrestrial events. But he did conclude that they were real experiences of great personal significance to the people who had them, and that dismissing them without serious investigation was a failure of intellectual responsibility. The scientific mainstream offers several alternative explanations. Sleep paralysis, a well-documented neurological phenomenon in which a person wakes during the paralyzed state that normally accompanies REM sleep and experiences vivid and often terrifying hallucinations, can account for many of the classic features of abduction accounts. The paralysis, the sense of a presence in the room, the intense fear, even the floating sensation. The consistency of the alien imagery across different accounts may reflect the cultural diffusion of a specific template. Once the gray alien image became widespread in pop culture following the Hills case and subsequent media coverage, subsequent experiencers began reporting encounters that matched that template. Hypnotic regression, which was used to recover many abduction memories, is now known to be a highly unreliable technique for recovering accurate memories. Under hypnosis, subjects are highly suggestible and tend to produce memories that are shaped by the expectations and questions of the hypnotist, often creating vivid but entirely false memories that feel completely real to the subject. And yet, the phenomenon does not neatly resolve. The consistency of the accounts across cultures, and before the widespread diffusion of the gray alien image in media, is harder to explain. And there are physical aspects of some abduction cases, marks on the body, implants found in the tissues of experiencers that have been physically extracted and analyzed, that resist easy dismissal. In the 1990s, physician Roger Leir removed what he described as unusual objects from the bodies of abduction experiencers. Some of these objects were analyzed and found to have unusual isotopic ratios and metallic compositions unlike anything in known meteoritic or industrial material. The scientific community has largely not accepted these findings, and the chain of evidence has been disputed. But the question of what these objects are remains unanswered. Here is the uncomfortable truth about the abduction phenomenon. If even a tiny fraction of the reported experiences reflect something real, something external and physical, the implications are almost unthinkably strange. And if none of them do, then we are looking at one of the most remarkable and persistent examples of mass cultural experience and false memory in human history, which is itself a deeply interesting phenomenon. What do you think? If 100,000 people, independently and sincerely, describe variations on the same extraordinary experience, does that require a physical explanation? Or does it tell us something profound about the human mind and its capacity to generate experiences that feel more real than anything we have encountered in ordinary waking life? Now we arrive at our 10th and final theory, and it may be the strangest and most counterintuitive of all. It is the theory that has been called the dark forest hypothesis, named for the science fiction novel of the same name by Chinese author Liu Cixin, part of his celebrated three-body problem trilogy. But while it originates in fiction, the logic behind it is cold and rigorous and has been discussed seriously by philosophers and scientists as a potential resolution to the Fermi paradox. The dark forest hypothesis begins with two premises that Liu Cixin argues are fundamental to all life in the universe. First, survival is the primary need of civilization. Second, civilizations continuously grow and expand, but the total matter and energy in the universe remain constant. These two premises, taken together, create a universe of potential conflict. Every civilization needs resources. Resources are finite. And crucially, you can never be certain of another civilization's intentions. Here is the critical move in the argument. Imagine you are a civilization that has developed the ability to detect signals from another civilization somewhere in the galaxy. What do? You might want to establish contact, to learn about them, to trade, to share knowledge. But you cannot know, with certainty, that they have the same intentions. And the consequences of being wrong are existential. If you reveal yourself to a civilization that is hostile, or that might become hostile as it grows and requires more resources, you have given away your position. You have made yourself a target. In this framework, every civilization in the galaxy faces the same dilemma. The risk of being discovered by a hostile advanced civilization outweighs the potential benefit of contact. The rational strategy for any civilization that thinks clearly about this problem is to hide. Stay silent. Listen but do not transmit. And if you discover another civilization, the safest strategy might be to destroy it before it can destroy you. The dark forest, in Liu Cixin's metaphor, is a universe in which every tree is a hunter moving silently through the dark, alert to the sounds of others, and prepared to eliminate anything that makes itself known. In this model, the cosmic silence is not the result of an absence of civilizations. It is the result of an overwhelming evolutionary pressure towards silence. Every civilization that has ever broadcast its presence into the galaxy, as Earth has been doing since the invention of radio, a bubble of electromagnetic signals now about 100 light-years across, has potentially made itself a target. There is a famous event in SETI history known as the active SETI debate. Active SETI refers to the deliberate transmission of signals into space with the intent of contacting other civilizations, as opposed to passive SETI, which involves listening for signals without transmitting. When scientists and philosophers have seriously discussed proposals to send intentional signals to nearby star systems, many prominent voices, including the late Stephen Hawking, have argued that this would be profoundly dangerous. Hawking famously said that if aliens visit us, the outcome might be much as when Columbus arrived in the Americas, which he noted did not turn out very well for the Native Americans. He argued that an advanced civilization capable of interstellar travel and communication would have long since mastered the resources of its own star system and would likely have moved on to others, making it potentially competitive rather than cooperative in its relationship to less advanced civilizations it encounters. The dark forest hypothesis is chilling not just because of what it implies about potential alien civilizations, but because of what it implies about our own situation. We have been broadcasting electromagnetic signals into space for over a century, unintentionally and intentionally. If the dark forest model is correct, and if there are advanced civilizations within a few hundred light-years of Earth, then they may already know we are here. And they have had time to decide what to do about it. What is their decision? Are they already on their way? Are we the ones who just stepped on a twig in the dark forest, and something has turned its head in our direction? Or, and this is the other possibility, is the dark forest model wrong? Is the universe not characterized by universal competition, but by something more like cooperation? The evolutionary biologist David Sloan Wilson and others have argued that cooperation is not an anomaly in evolution. It is a major driver of it. The history of life on Earth is in significant part the history of cooperative strategies outcompeting purely selfish ones, from the merger of bacteria that created eukaryotic cells to the social structures that allowed Homo sapiens to build civilizations. Perhaps the same logic applies at the scale of civilizations, and the reason we have not been contacted is not that everyone is hiding, but that we have not yet reached the threshold of development that makes us an interesting partner. Perhaps the universe is full of civilizations that are waiting not for us to be discovered, but for us to be ready. And perhaps that is the most important question of all. What would it mean to be ready? What kind of civilization, what kind of species, would be worthy of contact with a form of intelligence far older and far more advanced than our own? Are we there yet? Would a species that still wages war, still destroys its own environment, still cannot feed all its own members, be a welcome arrival on the interstellar stage? Or would we be viewed as what we might genuinely be, a young, dangerous, unpredictable, and potentially very interesting species at the most critical juncture of its development? Let us now take stock of what we have covered and what it all means together, because these 10 theories do not sit in isolation from each other. They form a web of ideas that together define the landscape of our current understanding, or rather our current not understanding, of one of the most fundamental questions we have ever asked. The rare Earth hypothesis says complex life is profoundly rare, possibly unique. The Great Filter says that something destroys civilizations before they reach our scale of interstellar visibility, and that something might be ahead of us. The post-biological universe hypothesis says that even if civilizations abound, they may have transformed into something so different from biological life that we would not recognize them. The Oumuamua theory raises the genuine possibility that alien artifacts have already passed through our solar system. The cover-up theory suggests that governments may possess knowledge they have not disclosed. The simulation hypothesis suggests that the nature of reality itself might be far stranger than any alien contact scenario we have imagined. The search for life in our own solar system reminds us that the most important discovery might be right next door. The ancient alien theory, however contested, reflects the deep human conviction that our origins are not entirely what we think. The abduction phenomenon confronts us with a persistent, widespread, and deeply strange human experience that defies easy categorization. And the dark forest hypothesis suggests that the silence of the cosmos might be not the absence of civilization, but the sound of fear. What these theories share, what connects them across their enormous differences, is a confrontation with the unknown that is both intellectually humbling and emotionally overwhelming. Because the question of whether we are alone is not just an astronomical question. It is a question about what we are. About whether consciousness is a cosmic accident or a cosmic principle. About whether meaning is something we construct in the dark or something the universe embeds in its very structure. And the evidence, taken in its entirety, the anomalous objects, the declassified videos, the congressional testimony, the scientific data from Europa and Enceladus and Mars, the persistent reports from credible witnesses, the mathematical inevitability of life across a universe of trillions of galaxies, that evidence does not allow for comfortable certainty in either direction. We cannot say confidently that we are alone. We cannot say confidently that we are not. We are in the most extraordinary epistemic position, on the threshold of an answer that would redefine everything, but not yet across it. Here is something worth knowing, and it is a fact that very few people are aware of, but that deserves to be much more widely known. In 2015, a team of researchers analyzing data from the Kepler Space Telescope noticed something remarkable about a star called KIC 846-2852, which astronomers quickly nicknamed Tabby's star after the astronomer Tabitha Boyajian, who led the discovery team. The star was dimming, not in the regular, predictable way that indicates a planet passing in front of it, but irregularly and dramatically, sometimes dimming by up to 22% of its total brightness. Nothing in the known catalog of natural astronomical phenomena could fully account for this behavior. One of the explanations considered seriously by astronomers was the possibility that the star was surrounded by a Dyson sphere or Dyson swarm, a megastructure built by an advanced civilization to capture the energy output of its star. The concept of a Dyson sphere was proposed by physicist Freeman Dyson in 1960 as a thought experiment about the theoretical energy needs of a sufficiently advanced civilization. A civilization that had mastered its home star's total energy output would be, by the classification system developed by Soviet astrophysicist Nikolai Kardashev, a Type II civilization on the Kardashev scale. By comparison, we are currently barely a Type I civilization, a civilization that harnesses the energy resources of its home planet. Tabby's star was observed extensively. Radio observations were conducted to look for the kind of electromagnetic emissions that a technological megastructure might produce. None were found. Subsequent infrared observations suggested that the dimming patterns might be explained by dust, by a swarm of cometary material, by the aftermath of some kind of planetary disruption. The alien megastructure hypothesis, while fascinating, does not have strong evidential support. But the episode was remarkable in one important respect. For the first time in the history of astronomy, the mainstream scientific community, serious professional astronomers writing in peer-reviewed journals, entertained the possibility that an observed astronomical phenomenon might have a technological, extraterrestrial explanation. That is new. That represents a genuine shift in the Overton window of scientific discourse about extraterrestrial intelligence. And it matters because it tells us that as our instruments become more sensitive and our catalogs become more comprehensive, we will encounter more anomalies. More things that do not quite fit. More KIC 8462852s. More Oumuamuas. More tic-tacs. And each time we do, we will face the same choice. Do we reach for the most conservative natural explanation? Or do we allow ourselves to seriously consider the possibility that what we are seeing is the product of a mind that is not human? There is a concept in philosophy of science called the principle of parsimony, more commonly known as Occam's razor. It holds that among competing explanations, the one that makes the fewest new assumptions should be preferred. For a long time, scientists applied this principle to UAP sightings and anomalous astronomical data in a very specific way. The natural explanation, however incomplete, was always considered simpler and therefore preferable to the extraterrestrial explanation. But is that actually true? Consider what it requires to believe that the universe is full of potentially habitable worlds, that life has emerged on Earth and is extraordinarily resilient and adaptable, that intelligence has evolved here, that we are somehow the only instance of this in a universe of 2 trillion galaxies and hundreds of billions of years of cosmic history. That requires an enormous number of assumptions. It requires us to be extraordinarily, cosmically, improbably special. In what sense is that actually the parsimonious explanation? The astronomer Carl Sagan, who was in many ways the conscience of SETI research in the 20th century, held the famous standard that extraordinary claims require extraordinary evidence. He was skeptical of UFO claims and believed that the evidence for extraterrestrial visitation did not meet that standard. But even Sagan, in his later years and in the pages of his last book, The Pale Blue Dot, expressed a deep and almost longing conviction that the universe must be full of life, that the chemical processes that generated life on Earth are not special, and that the universe is far too vast and too full of possibility for us to be the only experiment in consciousness. He believed in the importance of searching, of listening, of staying open. The search continues. The next generation of radio telescopes, including the square-kilometer array being built across South Africa and Australia, will be far more sensitive than anything that has come before. NASA's James Webb Space Telescope, already returning stunning images and data from the early universe, is capable of analyzing the atmospheres of exoplanets to look for biosignatures, chemical compounds in the atmospheres of distant worlds that would be difficult or impossible to explain without biological processes. Oxygen, methane, nitrous oxide, phosphine. The fingerprints of life, if they are there, written in light across light years of empty space. The Europa Clipper, as mentioned, is already on its way. A mission to Enceladus is in the early planning stages. The Perseverance rover is caching rock and soil samples on Mars that a future mission will return to Earth for analysis in the most sophisticated laboratories our civilization can build. The next decade may bring us more data, more anomalies, and more clarity than the previous century combined. But the data is only part of the story, because underneath all of these theories and discoveries and debates, there is something that is harder to quantify but perhaps more important to acknowledge. There is the experience of the encounter itself. The moment when a human being sees something in the sky or on the ground or in a laboratory readout that they cannot explain, and that does not fit into any of the categories that their culture and their education have given them. That moment is, whatever its ultimate explanation, a genuine human experience. and the way we as a civilization respond to such experiences matters. Throughout history, encounters with the inexplicable have gone one of two ways. They have either been suppressed and dismissed, filed away in the drawer of things we do not talk about, leaving the people who had them feeling isolated and disbelieved. Or they have been incorporated into our understanding of reality, however imperfectly, however incompletely, becoming part of the growing, evolving conversation about what is real and what is possible. We are at a moment in history where the second option is becoming more possible, where former intelligence officials testify before Congress about non-human craft, where NASA forms official study groups to investigate UAPs, where peer-reviewed papers in respectable journals discuss the possibility that an interstellar object might be artificial, where the James Webb Space Telescope looks for biosignatures in the atmospheres of worlds orbiting other stars. The question of extraterrestrial life is moving from the margins to the center of scientific and political and cultural discourse, and it is moving there for a reason. That reason is that the evidence is accumulating. Imperfect, contradictory, incomplete, and in many cases deeply controversial, but accumulating nonetheless. And at some point, the weight of it crosses a threshold. At some point, the sum of anomalies is no longer comfortably dismissed as noise but demands to be taken seriously as signal. Are we at that threshold? Are we approaching it? Think about this. Every major paradigm shift in the history of science has been preceded by a period in which the evidence was mounting but the culture was not ready. The heliocentric model of the solar system was mathematically supported before it was culturally accepted. The germ theory of disease was demonstrated before the medical establishment accepted it. Continental drift was proposed in 1912 and dismissed for 50 years before the evidence became undeniable and plate tectonics became foundational geology. In every case, the anomalies were there. The evidence was there. What was lacking was the willingness to see it. What is holding us back now? Is it the genuine insufficiency of the evidence? Or is it something deeper? Something about the magnitude of what the evidence, if confirmed, would require us to revise about ourselves? Because if intelligent life exists elsewhere, it changes everything. It changes our place in the cosmos. It changes our understanding of what consciousness is and how it arises. It changes our religious narratives about the specialness of human beings. It changes our political structures, our international relationships, our sense of what it means to be human. It is the biggest context shift imaginable. And context shifts of that magnitude are terrifying, even when they are also magnificent. Let us talk for a moment about something that rarely comes up in discussions of extraterrestrial contact, but that matters enormously. The psychological and sociological research on how human beings and human societies react to the prospect of contact with a radically different intelligence. In 1968, a report commissioned by the Brookings Institution for NASA concluded that the discovery of extraterrestrial civilizations would be one of the most significant events in human history, and that different societies and social groups would react very differently. The report noted that societies might disintegrate when confronted with the knowledge of a superior or simply radically different civilization. It suggested that religious and scientific communities might be among the most threatened by such a discovery. The report has since been cited in discussions of why governments might choose to suppress evidence of extraterrestrial contact, even with good intentions, out of concern for social stability. More recent research in psychology suggests a more nuanced picture. Studies, including a 2020 paper published in Nature Human Behavior by Michael Varnum and colleagues at Arizona State University, found that most people react to news of extraterrestrial life not with panic, but with cautious positive emotion, curiosity, and excitement rather than fear and dread. The researchers analyzed public reaction to past announcements of potential biosignatures, including the 1996 announcement of possible microbial fossils in the Martian meteorite ALH 84001, and found that the dominant public response was interested and relatively calm. The ALH 84001 case is itself worth pausing on. In 1996, A team of NASA scientists published a paper in the journal Science claiming to have found evidence of fossilized nanobacteria in a meteorite that had originated on Mars. The announcement was made at a White House press conference by President Bill Clinton. The paper described organic compounds, magnetite crystals, and structures resembling microfossils. It set off a firestorm of scientific debate that has never fully resolved. Subsequent analyses have offered natural, abiotic explanations for each of the features described. But equally, some researchers maintain that the biological interpretation remains viable. The meteorite, which was dislodged from Mars by an asteroid impact about 16 million years ago and landed in Antarctica around 13,000 years ago, remains one of the most studied rocks in the history of science. The scientific establishment did not break down. Society did not collapse. The debate was absorbed, analyzed, and continues to be scientifically productive, which suggests that perhaps we are more resilient than we give ourselves credit for. Perhaps we can handle the truth, whatever form it takes. And now, let us go somewhere that most science-focused discussions of this topic do not go, because the question of extraterrestrial life is not just a scientific question. It is a spiritual one. It is a question that touches on the deepest human needs for meaning, for place, for understanding of our own nature and purpose. And across the religions and wisdom traditions of the world, the responses to this question are more varied and more thoughtful than many people assume. Pope Francis has said that he would be willing to baptize an alien if one presented itself at the Vatican, characterizing extraterrestrial beings as part of God's creation. The Vatican Observatory, one of the oldest astronomical institutions in the world, employs professional astronomers and has been seriously engaged with the question of extraterrestrial life for decades. Jesuit astronomer Guy Consolmagno, director of the Vatican Observatory, has written extensively on the theological implications of life elsewhere in the universe and has concluded that it would not undermine Catholic faith but might deepen it. Islamic scholars have debated the implications of extraterrestrial life within the framework of Quranic theology. The Quran contains the verse, "And among his signs is the creation of the heavens and the earth, and the living creatures that he has scattered through them." Some Islamic scholars interpret this as suggesting that God has created life throughout the cosmos, making the discovery of extraterrestrial life not a threat to faith but a confirmation of divine creative power. Buddhism, with its concept of multiple worlds and its absence of a creation story that requires humans to be cosmically central, arguably has the least theological anxiety about the discovery of extraterrestrial life of any major world religion. The diversity of religious responses to the prospect of contact mirrors the diversity of scientific and philosophical responses. There is no single human reaction to this question. There is a spectrum of responses, from fear to wonder to anger to reverence, shaped by culture and education and temperament and individual psychology. And all of those responses are real. All of them matter. What matters most, perhaps, is not which response is correct, but that we are having the conversation. That after thousands of years of looking at the stars and wondering, we are now, for the first time in human history, in a position where the question might actually be answerable within the lifetimes of people alive today. The James Webb Space Telescope, which began science operations in 2022, has already detected CO2 in the atmosphere of an exoplanet for the first time and has begun to analyze the atmospheres of worlds in the habitable zones of other stars. Its successor, the Habitable Worlds Observatory currently in development, will be specifically designed to directly image Earth-like exoplanets and analyze their atmospheres for biosignatures. If life is out there on a world with a visible atmosphere, we may have the technology within a decade or two to see its chemical fingerprints. SETI research continues with new tools and new strategies. The Breakthrough Listen program, launched in 2015 with a $100 million commitment from investor Yuri Milner, is the largest and most comprehensive SETI program in history, using some of the most powerful radio telescopes on the planet to listen across the broadest frequency range and deepest catalog of stars ever undertaken. It has already detected and published data on thousands of radio frequency interference signals, developing machine learning tools to distinguish between human-made interference and potential extraterrestrial signals, refining the haystack in which we are searching for the needle. There is also an interesting and increasingly discussed possibility at the intersection of SETI and technology that deserves attention. The question of whether artificial intelligence might be better at detecting extraterrestrial signals than human researchers is now being actively studied. Machine learning algorithms can analyze enormous amounts of data, identify subtle patterns, and flag anomalies that human researchers might miss. If there is a signal out there in the data we have already collected, buried in the noise of decades of radio telescope observations, AI might be the tool that finds it. In 2023, a team using machine learning techniques reanalyzed old radio telescope data and identified a candidate signal from the direction of a sun-like star about 30 light-years away. The signal, which was detected in data originally collected in 2016, had the characteristics that SETI researchers look for. It appeared to come from a single point in the sky. It drifted in frequency in the way a signal from a planet would drift as that planet orbited its star, and it was not immediately explained by any known source of radio frequency interference. Subsequent efforts to confirm or redetect the signal have not been successful. But the methodology of using AI to mine existing data for anomalies is a powerful one, and there is no telling what else might be buried in the archives of decades of radio telescope observations. What strikes the thoughtful observer about this entire field, taken as a whole, is how many different converging lines of inquiry are all pointing in the same direction, not necessarily toward definitive proof of extraterrestrial intelligence, but toward the conclusion that the universe is far more alive, far more complex, and far more full of possibility than the scientific mainstream was willing to acknowledge even 20 or 30 years ago. The discovery of hydrothermal vents on Earth and the extremophile ecosystems that thrive around them expanded our sense of the conditions under which life can exist. The discovery of thousands of exoplanets expanded our sense of the ubiquity of worlds. The detection of complex organic molecules in space, including amino acids in meteorites and sugars in interstellar clouds, expanded our sense of the pervasiveness of the chemistry of life. And the growing institutional seriousness with which governments and scientific bodies are approaching the UAP phenomenon suggests that the anomalous data, whatever its ultimate explanation, is too persistent and too credible to simply wish away. Let us talk about something specific and relatively recent that illustrates how rapidly this landscape is changing. In June 2023, at a hearing of the House Oversight Committee, David Grush's testimony included the claim that the U.S. government has been in possession of non-human craft and biological material for decades and has been concealing this information through the misuse of special access programs. He stated that this information had been withheld not just from the public but from Congress itself, which would represent a profound failure of governmental transparency and accountability. His claims were investigated by journalists at The Debrief, a national security publication, and by Leslie Kean and Ralph Blumenthal, two journalists whose previous reporting on the UAP phenomenon for the New York Times in 2017 had been instrumental in breaking the story of the Pentagon's ADA program, the Advanced Aerospace Threat Identification Program, a classified Pentagon program that investigated UAPs from 2007 to 2012 and whose existence was officially confirmed in 2017. Kean and Blumenthal reported that Grush's claims were being taken seriously by intelligence community investigators. In December 2023, a bipartisan amendment sponsored by Senators Chuck Schumer and Mike Rounds, clearly modeled on the JFK Records Act, was included in the National Defense Authorization Act. It called for the creation of a review board to oversee the declassification and release of government UAP records, and established a legal framework that would require any private contractors in possession of non-human materials or craft to turn them over to the government. The final version of the amendment was significantly watered down before passage, but its very existence, introduced by the Senate Majority Leader and a senior Republican senator and included in the primary annual defense legislation, represents something genuinely unprecedented in the history of government engagement with the UAP phenomenon. Whether Grush's specific claims are accurate or not, the governmental response to them represents a categorical departure from the decades of official dismissal and debunking that characterized government policy on this subject for most of the 20th century. The question is no longer whether the government takes this seriously. It clearly does. The question is what it knows, and when we will be told. Now let us venture into the most speculative, most philosophically rich, and most personally resonant territory of our entire journey. Because beyond all of the government programs and congressional hearings and telescope data and abduction reports, there is a question that sits at the very core of this entire subject. A question that is in some ways the most important and in other ways the most unanswerable of all. What do they want? If they are out there, if they have visited, if they are watching, if they have in some sense been in contact with governments or with individuals or with our electronic signals or with the chemistry of our biosphere, what are they doing here? What motivates a form of intelligence so advanced that it has solved the problem of interstellar travel, something we have barely begun to theorize our way through, to take an interest in a small, young, violent, confused species on a medium-sized planet orbiting an unremarkable star in one of the outer arms of a middling galaxy? The answers that have been proposed cover a staggering range, from the comforting to the terrifying. On the hopeful end, some researchers and thinkers have proposed that advanced civilizations might take an interest in us precisely because we are at a critical juncture in our development, the period of maximum danger and maximum possibility, and that their interest might be essentially protective or educational. The Federation model, as it is sometimes called in SETI discussions, imagines a galaxy in which mature civilizations form cooperative networks, and that young civilizations like ours are monitored and perhaps gently guided toward the choices that allow them to survive the Great Filter. This is essentially the premise of the Prime Directive in Star Trek, the fictional embodiment of a real philosophical position that has been seriously discussed among SETI researchers. On the more neutral end, researchers like John Ball proposed in 1973 what he called the zoo hypothesis, that extraterrestrial civilizations are aware of our existence but have deliberately chosen not to interfere with our development, maintaining a kind of cosmic preserve in which we are observed but not disturbed, allowed to develop according to our own internal logic without the distorting influence of contact with a vastly more advanced civilization. The cosmic silence, in this model, is deliberate and protective. They know we are here. They are watching. They have decided not to nod. And on the more disturbing end, there are scenarios in which the goals of an extraterrestrial intelligence are so alien to our own, so shaped by billions of years of different evolutionary history and different social and technological development, that we might not be able to understand them at all, let alone align with them. As Arthur C. Clarke wrote, any sufficiently advanced technology is indistinguishable from magic, but the obverse is equally worth considering. Any sufficiently alien intelligence may be indistinguishable from a natural phenomenon. We might be interacting with extraterrestrial intelligence in ways we do not recognize precisely because we are looking for something that acts like us. The astrophysicist Martin Rees has written about the possibility that the most advanced intelligences in the universe might have transcended the need for planets or even for stars, operating in environments of extreme density or temperature that biological life cannot access or even conceptualize. Their equivalent of cities might be black holes or neutron stars. Their equivalent of communication might be gravitational waves or quantum entanglement. We might be as invisible and irrelevant to them as the bacteria in our intestines are to us, present but unnoticed, living out our lives in an ecosystem we do not comprehend within a larger system we cannot perceive. Or perhaps, in the most vertiginous version of this thought, we are not irrelevant at all. Perhaps we are relevant in exactly the way that bacteria in the gut are relevant to the larger organism. Not as partners or subjects of interest, but as components. Functional parts of a system whose larger purpose we are not equipped to understand. These are not comfortable thoughts. But discomfort, in the face of genuine mystery, is the appropriate response. Comfort, in the face of the genuinely unknown, is a kind of intellectual fraud. The universe does not owe us comfortable answers. What it might owe us, or what we might demand of it, is honesty, clarity, evidence. The courage to look at the data, all of it, without filtering it through the lens of what we are culturally prepared to accept, and to follow it wherever it leads. And this is perhaps the most important thing to say as we move toward the end of our journey through these 10 theories. Wherever it leads is going to be more interesting than where we are now. Whatever the answer turns out to be, whether we are alone or surrounded, whether the universe is a dark forest or a garden, whether the cosmic silence is the silence of absence or the silence of waiting, the answer will be more astonishing, more complex, and more transformative than anything we have yet imagined. The history of science is the history of discovering that reality is bigger than we thought. That the Earth is not the center of the solar system. That the solar system is not the center of the galaxy. That the galaxy is not the only galaxy. That the universe had a beginning and may have an end. At every step, the expansion of understanding has been accompanied by a recalibration of our sense of place and scale and significance. Not an erasure of meaning, but a deepening and enriching of it. The discovery of extraterrestrial life, or extraterrestrial intelligence, will be the next step in that history. And based on the evidence currently available, based on the mathematics of the cosmos and the growing body of scientific data and the testimony of credible witnesses and the institutional seriousness with which governments and scientists are now approaching this question, it is not a step that seems far off. It is, perhaps, the next step. The one that happens in the lifetimes of people alive today. Now, before we leave this space of ideas and questions and possibilities, there is something we need to address directly. Something that is easy to overlook in the excitement of these grand theories and spectacular possibilities, but that is in some ways the most human part of this entire story. Every one of these theories, from the rare Earth hypothesis to the dark forest, from the cover-up to the abduction phenomenon, from the post-biological universe to the search for life in our own solar system, every one of them is a human response to a fundamental uncertainty. And the way we respond to fundamental uncertainty tells us something essential about who we are. Some of us find the uncertainty terrifying. We fill it with fear, with conspiracy, with a conviction that someone must know and must be hiding it. The fear is real, and it is not irrational. There are things to be afraid of, real risks and real unknowns and real possibilities that are genuinely disturbing. Fear, in the face of the unknown, is a reasonable response. Some of us find the uncertainty exhilarating. We fill it with wonder, with curiosity, with a conviction that the universe must be generous, that it must contain more life and more minds and more stories than we can currently imagine. The wonder is also real, and it is also not irrational. There are things to be awed by, real beauties and real possibilities and real discoveries that are genuinely breathtaking. Wonder, in the face of the unknown, is also a reasonable response. Most of us, if we are honest, find the uncertainty both terrifying and exhilarating, dreadful and magnificent, a source of both the deepest anxiety and the deepest fascination we have ever encountered. And that mix of emotions, that complex and sometimes paradoxical response to the possibility of the non-human, is itself one of the defining characteristics of what it means to be human. We are the species that knows enough to understand the scale of what we do not know. We are the species that can look up at 2 trillion galaxies and feel both small and significant at the same time. We are the species that can ask the question, are we alone? And understand what it would mean in every possible direction. That is not nothing. That is extraordinary. Whether we are cosmically alone or cosmically surrounded, the fact that something in this universe can ask that question and mean it, can lie awake at night wondering about the nature of other minds and other star systems, can dedicate a life's work to listening for a signal from across the light years, is itself a kind of miracle. You are a part of that. Right now, listening to these questions and sitting with these ideas and feeling that mixture of wonder and unease, you are part of the only conversation in the known universe that is asking what else is out there. At least, the only one we know of. Maybe that is the most important fact of all. Not what they are or where they are or what they want, but that we are here asking. That we have been asking for as long as we have been human. That the question itself, that ancient, persistent, unanswerable and yet necessary question, is one of the things that makes us what we are. The night sky is still up there. Those 2 trillion galaxies are still turning. The signals we have sent, the light from our cities and the electromagnetic waves from our broadcasts and the Voyager probes drifting silently outward at the edge of the solar system, those are still moving through the dark, carrying their tiny encoded messages of our existence. And somewhere, in a direction we cannot yet point to, in a time we cannot yet specify, something might be receiving them. The X-Files theme plays not because it is campy or ironic, but because it captures something real. That suspicion of a truth that is out there, just beyond the edge of what we are officially permitted to know. The sense that the universe is full of secrets, and that we are very, very close to some of them. We are close. Something extraordinary is coming. And whether it arrives in the data from a telescope, or in the testimony of a pilot, or in the readout of a mass spectrometer analyzing a Martian rock sample, or in a signal that no one expected from a direction no one was looking, when it comes, you will want to have been paying attention. You will want to have been one of the people asking the question. So keep asking. Keep looking. Keep that mixture of wonder and dread alive. Because the universe, strange and vast and old and full of secrets that we are only beginning to suspect, that universe is listening. And it may, at any moment, answer. The silence stretches on. The stars burn bright. And in the dark spaces between them, something that we cannot yet name waits, patient and ancient, and perhaps as curious about us as we are about it. This is not the end of the story. It is barely the beginning.